So, good morning, students. Welcome to 7 classes. So, today we are going to discuss a very important topic of coordination compounds, that is crystal field theory. Okay, that is crystal field theory. First of all, we will understand that what is the basic point of this theory, and then we will understand that how they have given the further requirements and that how that ligand is bonding with that metal. Okay, see, the basic point, the basic purpose of this theory was that it says that the bonding between the ligand and the metal is purely ionic. Okay, what it says that there is ionic bonding between metal and ligand. Ionic bond, you guys very well know that the bond which is formed as electrostatic interactions, right? Whenever one species is losing the electron and another one is gaining the electron, and the positive and negative charge they possess due to loss and gain of electrons, at that time the bond which is formed between that electrostatic, between those charges, that is called as an ionic bond. So that is what this theory says, that the ligand and metal, they are having which type of bond? Ionic bond. Okay. Now we know that d orbitals, okay, all the d orbitals, they are degenerate. Meaning of degenerate or degeneracy is that all of them, they possess the same energy. These are dxy, dyz, dzx, dx square minus y square, and dz square. Okay, they all are degenerate, means they are having the same energy. How they are having the same energy? Under what conditions they possess the same energy? Under what conditions this degeneracy is applied? That is when the charge around that orbital is symmetrical. Okay, when all the charge around this orbital, that is symmetrical, only at that time this degeneracy will exist. But when the ligand will approach the metal ion, okay, at that time this charge becomes unsymmetrical. Okay, when ligand, it approaches the metal, at that time the electron cloud, okay, electron cloud made of that, those charges, of those positive and negative charges, that cloud becomes unsymmetrical. And because that cloud becomes unsymmetrical, these orbitals, they break, they split. Okay, they split on the basis of the type of energy. Okay, the higher energy ones, they will be at a higher position, and the lower ones will be at a lower position. Okay, so because of the unsymmetry of that charge, they will split. Now we will understand the splitting of these orbitals. Okay, this splitting of orbitals, that is called as crystal field splitting. Okay, so what is that crystal field splitting? Crystal field splitting is the splitting of d orbitals because of the unsymmetrical electron cloud present around that orbital. Okay, now first we will understand this crystal field splitting in octahedral complexes. Okay, and that is mainly asked in the exam. Okay, every time this is the pet question of CBSE, asked a number of times. See, now in octahedral complexes, what happens that we are having these 5 orbitals which were degenerate, right? In them, they will split into 2 parts. The first ones, these 2 and these 3. This is dx square minus y square and dz square. This is dxy, dyz, and dzx. These 2 orbitals, they are given a name called as delta O. Okay, and they have been given the name T2G. Okay, T2G and EG. This is Eg. Okay, T2G and Eg. Now they are having the energy difference of 3 by 5 delta O. Okay, and these are having the energy difference of 2 by 5 delta O. Okay, now the question arises that why the Eg orbital dx square minus y square and dz square, they are having the higher energy, why T2G orbitals txy, yz and zx, they are having the lower energy? What is the reason for that? See, the reason for this is that these orbitals, they are lying on the axis. Okay, they lie on the axis, and when the ligand approaches, so there becomes repulsions. There are a lot of repulsions which happens. Now if there will be repulsions, stability will be less and energy will be higher. Okay, why these are having the higher energy? Because these are present on the axis. Okay, these are present on the axis. And why they are having the lower energy? Because these orbitals are present in between the axis. Okay, because the Eg orbitals, they are present on the axis, so when the ligand approaches them, the repulsion between the electrons are very high. Okay, and as the electronic repulsions are high, so that is why they are having the higher energy. Okay, so this is the case that how splitting of the orbitals happens in the octahedral complexes, and why that splitting happens, that I already explained you over here, because of the unsymmetrical electron cloud. Okay, now there are two things, there are two possibilities. Now there are two cases. The first case is that when delta O, this crystal field splitting energy, is less than pairing energy. Okay, when it is lesser than pairing energy, first of all, what will happen? The electron, it will come in the lower orbital, in the lower orbitals which are having the lower energy, right? Now the question is that the fourth electron, what will happen to the fourth electron? If it will go to the Eg orbital, or if it will start pairing with this, it will go in this T2G only. That is the question now. So for that case, we are having the two cases, that if delta O, that is crystal field splitting energy, is lesser than pairing energy, okay, then the fourth electron will enter into the Eg orbital. Then the configuration that we will get is T2G3 and Eg1. Then the fourth electron will enter into the dx square minus y square orbital. Okay, and secondly, if delta O, it is greater than the pairing energy, in that case, the configuration that we will get is T2G4 Eg0, means the fourth electron, it will enter into this orbital only, that is dxy only. So now this is the case exactly. Okay, if delta O is lesser, then the electron will go into the Eg, dx square minus y square, and if delta O is higher, then there will start pairing. Okay, this is different, this is actually opposite. Don't ever get confused that if pairing energy is higher, then pairing will not happen. No, if pairing energy is high, then pairing is not going to happen, then the electron will go into this Eg orbital. Okay, and if pairing energy is less, then pairing will happen. Okay, so keep this thing in mind. Now how it will be determined? Okay, that will be based upon the type of the ligand. Okay, and that we get from the spectrochemical series. Okay, in which the ligands are arranged on the basis of their on the basis of the field they produce. Okay, so that is a different topic. Okay, so on the basis of the ligands, this will be decided. Now, those ligands in which the fourth electron enters in this Eg set, they are called as weak field ligands. Okay, and these are also called as high spin complexes. Those complexes are called as high spin complexes. And the one in which the electron is entering in the T2G only, they are called as low spin complexes. Okay, they are low spin complexes and are also called as strong field complexes. Okay, so this is exactly the case in which we have discussed about this crystal field splitting. Okay, thank you.